All right, today's work is extremely specific. We are far enough into the book now that a lot of stuff you learn is hardly going to be used, but you do want to make sure you learn it because since it will be used, it's important for you to at least know that you can learn a random process. Again, my general idea of a diploma or a degree is that you can learn random material on time, which the on time is important, but the fact that you can learn something random on time is important as well. So this is just a section where your general idea is to make sure you can learn how to do this by the time you take the test. And I don't think it's bad. Again, as long as your habits have been good, you should be okay. So we've learned that the general formula for an exponential function is y equals ab to the x, where y represents the final amount, a represents the starting amount, b represents the growth rate, and x represents time. This formula works well when growth and decay is occurring in a manner that we can quantify. So hourly, daily, weekly, monthly, yearly, and so on. Each of those words could be converted to a number based on a year, which is usually what you end up doing. If you were doing hourly, well, however many hours there are in a year, that would be your number. Daily, you would use a 365 in terms of something to deal with that x. Weekly, you'd be using 52 because there's 52 weeks in a year. You'd be using 12 for monthly because there's 12 months in a year. And of course, this works best with yearly because typically you're just going to use one for your time and go from there. But anyway, each of these words can be converted into a number based, and we already discussed it, so we don't need to. But what if growth is occurring continuously? There is no number to represent the number of recurrences in 1 year because we'd be going to the number infinity, because right now it could have actually compounded 1,000,000 times from now to now. So if it's continuously changing the value of whatever's in there, a new formula is needed because you cannot quantify something that's going on continuously. So this is where your introduction starts. Make sure you copy these two things down. One is y equals AE, again, the natural number E. So AE to the KT, or y equals AT to the negative KT. We know that A still represents your starting value, Y still represents your end value. We know that T represents time. E, of course, is the natural log, so that leaves only one variable that we don't know about, and that is K. K represents the rate of continuous growth or continuous decay. Again, positive if it's growing, negative if it's decaying. Make sure you keep that in mind and that you use that to your advantage as you work. You might have encountered the formula for finding the amount of money in an account compounded continuously. It's I equals PERT. I think you might have seen that at some point. I know I saw it at some point in middle school before I got to Algebra 2. But if you look at these similarities, P was your initial principal. That's your growth, or that's your starting point. E is here. That is a growth rate, which is usually your percentage. That's your growth rate. That's the percentage you're using. T for time. So you've already kind of worked with it. It's just, again, the specificity of being continuous is really what we're looking at. Because there are not many specific issues for general formula that are worthy of Algebra 2 status, we're going to focus on two questions that are worthy of this class. Again, just be sure to pay attention to the explanation and make any extra notes on your paper that you need for a better understanding. So wrapping up this unit is going to be pretty basic because it just comes down to two questions that we're going to talk about. So a substance was analyzed and found to have a half-life of 5,090 years. Use the formula for continuous decay to create a general formula for the decay of substance. Now, half-life means that if A is our starting point, then we are going to 0.5A. That is the essential key of what you need. So make sure you write that down. Make sure you highlight that as your connection between your starting point and your half-life. So when we go to use that, we're looking at y equals AE to the negative KT. And I'm using negative KT because it is decaying. Half-life means that it's only around, that it decays, and it takes this many years to get to half of whatever was there initially. So with that being said, we now need to plug some things in. Your ending point would be the halfway mark because I want to know when it's going to be half of what was there. So this is going to be 0.5A equals AE to the negative K, and T in this case is going to be time that it takes, which is 5,090. All right, so again, make sure you remember this is your half-life. This is your starting amount, which we don't know because we don't know what it started off with. Natural log, we're looking for K in the end, and 5090 is the number of years it takes for it to get to half-life. Now here's the beauty of this formula. A and A are on both sides, which means if I was to randomly divide both sides by A, I would get 0.5 equals e to the negative 5090k. I'll just go ahead and simplify that as is. Now, we have k up here. We can't get rid of the 5090 until we get rid of e, which means I want to do the natural log of 0.5 equals natural log of e to the negative 5090k, which means I need to copy my ln of 0.5 and bring down, negative 5090k. The next thing I want to do, because you will be required to show this work on your Math XL, and it should look exactly like this, is I'm going to divide by 5090. So natural log of 0.5 over negative 5090 equals k. Again, that's going to be one of your boxes, and then it's going to have k equals right under that. So now just plug that in. So natural log of natural log 0.5 over negative 5090. 90 is, and you want to go to 5 spots, so 1 2 3 4 5 0 0 0 1 4. So that's your k, but the general formula is going to not just be this. This is a rate of change, but remember that we're decaying. So the key thing on your homework when you do this is remember it's negative kt, so it'll be y equals ae to the negative 0.00014 t. That is your formula for the half-life. The key point is getting from here all the way down safely. But actually, no, that's not. We're not there yet. So that is just how you find it. And so in order to make this thing right, we're going to do another one because again, we are practicing a specific skill to make sure we've got it. So half-life of 4752. Again, the first thing we want to start out with is the general formula, which is y equals ae to the negative kt. Our ending amount, because we're talking half-life, is 0.5a. Because remember, if we're starting with a, we want to end off with 0.5 of a, so half of a. And we don't know k, but we do know t. The half-life is 4752. It's just a matter of, habit after that. Now we're going to go ahead and recognize that a is on both sides, so we get 0.5 equals e to the negative 4752k, because remember I'm just multiplying those out. From there I want to get rid of the e, so I do natural log of both sides. From there my e's cancel out, so ln of 0.5 equals negative 4752k. From there again, I want to divide the 4752, and I know the computer is going to put the negative there, but you should be fine putting it on the bottom. If it says you're wrong because of that, it means you messed up somewhere else. But that is k, and so again, we're going to take this thing and let's look at this real fast, just for the sake of using patterns. Hopefully, you see the pattern here. I'm pretty much typing the same thing on top. The only thing changing is the bottom, but I do want you to show your work just to make sure you can get through it. But 4752 0.00015, so k equals 0.00015. After that we want the formula, so y equals ae to the negative, because it's decaying, 0.00015 t. So whatever amount we had, it would be cut in half at this rate. It just depends on how much time we're talking about. All right. So other than that, like I said, that's the general part that you have to know how to do. Now, if you don't know how to do this step, you will not know how to do the next two we're going to look at. And this is really what the half-life is for. And they usually use carbon 14, but carbon 14 would be the same answer in both of them, and I want you to have to do some work. So I just made it substance A. So let's just assume that there is a substance inside of bones that is there and has a half-life of whatever amount of years. So paleontologists examining bones of a prehistoric animal estimates they contain 5% of substance A as it would have contained when the animal was alive. So in other words, they checked it, they found substance A, and they realized that, this is just 5% of what should have been there based off of what they know about the animal. If the half-life of that substance is estimated to be 2,000 years, how long ago did the animal live? So what we're looking at here is we need to know the half-life, because we don't know the we know the half-life, but we need a formula. And so in order to get the formula, we have to do the half-life thing, where we do 0.5a equals ae to the negative k times 2282, which means we do 0.5. And because I'm not showing work here, and because we've already done it, I'm going to take a couple of shortcuts, hoping I don't mess up. Here's what I know. When I do the natural log of this side, and again, you can't do this on MathXL, but I know I'm going to get natural log of 0.5. It's just going to cancel out anyway, so why not just bring it down as is? Again, when I did that step before, 2 times, we saw it, that the natural log step pretty much just brought down what was there. And the natural log step pretty much just brought down what was there. So again, using your vision and skipping small things, I'm just going to skip that small step because it doesn't really hurt. And then in the end, you're just going to divide by that. So natural log 0. I need to put that in fraction mode, over negative 2282. Again, 5 digits, 00030. Alright, so that is my k. Now I'm going to use that in the general formula, which is y equals ae to the negative 0.00030t. So that is why we need the formula. Here's the thing. It has 5% of substance A. So whatever A is, we want to do 5% of it. So we would do 0.05A equals, because again, whatever we had here, it's 5% of what it would be. We don't know the starting amount. Actually, whatever it is, it doesn't matter if we know the starting amount, because we know what's going to happen to the A's. The key thing is we know that wherever you started, you had 5% of what's there, and we're looking for the time. So we end up back in a similar problem to where we were. The A's cancel. 0.5 equals e to the negative 0.00030t. Again, taking the natural log, I know it's going to cancel the e, so I'm going to save myself a step. And then knowing I'm just going to divide by that number. So again, fraction here, natural log of 0.5 divided by, oh, I'm messing up. It's 0.05. That's a big difference, because that's 50%. I need 5%. So natural log of 0.05, sorry, over negative 0.0030, which you really don't need the 0, gives us this answer. I'm just going to go to the nearest year, unless it says anything else, 9986. And that's how they determine something has been around for 9,000 years before that date. So again, the difference here is if you don't know how to find k, then you can't do the second part. But you've got to make sure you understand 5% of substance A is what you're going to use as your ending point, because you still don't know the starting point. But the good news is, as we've learned, the A's cancel, giving us a problem that we can actually work with. All right. One more just to make sure we've got it. Paleontologist, blah, blah, blah. Let's make this 3%. Equals 3% of substance A. And again, if the half-life of substance A is 3,205 years, how long ago did the animal live? Same thing. We have to first off find a formula. And so to find that formula, we are going to, well, I'm just going to go ahead and use my head here. Again, feel free to make the formula, but let me just show you something real fast. All of my stuff and all of my problems, again, this is where you want to pay attention. That's what math is, the science of patterns. In the first one, let me get this to zoom to focus. In this one here, we ended up doing natural log of 0.5, which is the half, divided by the number of years. Okay. And the ones before it, let's look at what we did. Natural log of 0.5 divided by the negative number of years. Look at that. And let's look at another one. Natural log of 0.5 divided by the negative number of years. So why would I make myself work that hard if the teacher is not forcing me to show work, and I'm pretty sure I know what I'm doing here. So what I'm going to do for my value of k is I'm going to do natural log of 0.5, because that's usually how it started, because it was half-life, over the negative number of years. So yes, it seems like a shortcut, but it's really not, because I'm not making you show work on this. It's a shortcut that I'm used to, and I just explained the whole logic of everything ended up the same. So 1, 2, 3, 0.00022. So my formula is y equals a e to the negative 0.00022t. So without having to go through all that work like the Math XL is going to make you do at some point, I should know how to kind of get to that point. And again, after you practice it a few times, you'll see what I'm saying, and you'll know to kind of skip over whatever you can. And if not, just do the full step. But I did at least show you the pattern that you're looking for. Now, in terms of what's going on, again, we want it to be 3% of substance A. So again, that means that wherever we started, we want it to be 0.03 of A equals AE to the this part here. Again, your A's cancel out. Honestly, at this point, you can go ahead and put your LNs because you know your A's are gone, but I'm not going to do that because it's just me showing too much human side to myself. But I am going to skip the ln part because I know the natural log and the e goes away. So natural log of 0.03 equals negative 0.00022t. Dividing by 0.00022. So natural log of 0.03 over negative 0.12322 gives me 15939. So this would have been around 15,939 years ago. So that's how whenever they tell you that a dinosaur is around X amount of years or billions of years, that, you know, that's what it is. Which makes me question, well, why are we in the year 2000 if something has been billions of years old? It's kind of scary that you had to restart it to 2000 if we've actually been around for longer than that. But anyway, this wraps up for your material for the chapter, but let's discuss some key points for you to maximize your Chapter 7 grade. Very important points because I like to give my students a chance to make the best out of their opportunities. First off, your pretest goes up Tuesday, which should be tomorrow for some or today for others. You must have a 90% on all assignments to get a pretest as usual. Now here's the thing. Your test also goes up Tuesday, which is again I don't know what day it is, but it's the week that I assign this stuff. You don't have to officially take it until March 12th. But there is a bonus for students who are working on it at an exceptional level. So for my students who are working for 90% to get to the pretest, if you get your pretest to a 50%, your test unlocks. And you can take it anytime before we return from spring break. So actually I'd say by the March 5th. So by March 5th, you have to take this test. But when you take the test, it is a test run for you, meaning that if you take it and you don't do as well as you like, it doesn't hurt you. I'm not going to put that score in. I'm going to put your second score in, or if your second score is lower, I'll put your initial score in, but at least you have something to kind of go off of. But again, for those students who can get to 90% on your homework, I want you to have the extra benefit of possibly not having to work after you take the test, because you could actually take that last week and work on something else. So again, if you take the test ahead of time after getting your score to a 50, which I would probably try to get above 50, but let's say that because it closes Friday, you only can get to a 50 for Friday, at least you can take the test and see what happens. Because to me, to get this to a 50 means you had to have a 90% on all your assignments, which means that you've been working like you're supposed to work, or at least at a higher level than usual. So again, if you take that test and you like the score, you are done for the quarter. Now, you still have to come to class and do all the stuff so I don't mark you absent, but you don't have any more work for math because Chapter 7 test is it. Now, if you have makeups, feel free to work on those makeups. Feel free to work on all homework. But in terms of the Chapter 7 test, you would be done if that score was good. If not, then you could actually just use the next week to study and ask questions over the questions you missed, which is a good thing. There is no penalty for students who can't get a 50% on their pretest as usual. but you will be forced to wait until after spring break to make your test, because if you don't get to the pre-test to a 50, then the test is just going to be locked, because remember, it closes on Friday, and so you'll just have to wait and make sure you get all your assignments up to 70%, which, with the fact that we have a week off, if you can't get your assignments to 70% by the 12th of March, it's either because you are just being stubborn or you really aren't working at all in general. So just, again, contact me if you have any issues. I'll be glad to help. Good luck, and again, congratulations for getting through the third quarter.